If you wire an array as an input to a for loop, Labview provides the option to automatically set the count terminal of the for loop to the size of the array using the auto-indexing feature. The auto-indexing option can be enabled or disabled by right-clicking the loop tunnel wired to the array and selecting Enable or Disable Indexing. If auto-indexing is enabled, each iteration of the for loop is passed the corresponding element of the array. When you wire a value as the output of a for loop, enabling auto-indexing will output an array. The array will be equal in size to the number of iterations executed by the for loop and will contain the output values of the for loop. Let's go through an example in Labview. Create a new VI in Labview. Go to the block diagram and create and initialize two 1D array constants containing 6 numeric elements. Just as we did before, we'll drop an array constant show on the block diagram. Then we'll place a constant numeric into the array shell. Resize the array to show 6 elements. Then resize the elements inside the array. To save time, let's make a copy of this array and place it below the original array. It's important to know that you don't have to initialize your array values to the same values that I'm using. However, if you want to use my values so that you can check your results, that wouldn't be a bad idea. Now, go to the front panel and create a 1D array of numeric indicators. Change the numeric type to a 32-bit integer by right-clicking on the array and selecting Representation I32. Now, go back to the block diagram and create a for loop. Place an add function inside the for loop. Wire one of the array constants into the for loop and connect it to the x terminal of the add function. Then, wire the other array constant into the for loop and connect it to the y terminal of the add function. Finally, wire the output terminal of the add function outside the for loop and connect it to the input terminal of the array of numeric indicators. Go to the front panel and run the VI. Expand the array of numeric indicators to 6 elements. Notice that each element in the array is populated with the sum of the corresponding elements in the two array constants from the block diagram. Be aware that if you enable auto-indexing on more than one loop tunnel and wire the for loop count terminal, the number of iterations is equal to the smaller of the choices. For example, in this VI, the for loop count terminal is set to run 15 iterations. Array 1 contains 10 elements, and array 2 contains 20 elements. When we run this VI, the for loop executes 10 times, and array result contains 10 initialized elements. Verify this by expanding array result. As you can see, array result contains 10 elements, which are the sum of the first 10 elements of array 1 and array 2. As mentioned before, 2D arrays can also be created programmatically using nested for loops. This VI uses nested for loops and auto-indexing to create a 2D array programmatically. The outer for loop creates the row elements, and the inner for loop creates the column elements. If we run this VI and expand the array, we'll notice that the array is initialized with 4 rows and 6 columns. This concludes our discussion of arrays. Now, let's move on to creating and manipulating clusters.